Welcome to One Little Coder's weekly roundup of AI news. In this week, we have got four sections. The first one starts with papers, then we have got five models to discuss. We've got a couple of tools and techniques, and finally, we'll look at some general news. Let's get started with the papers. First paper that we're going to look at this week is HyperAttention. The paper that says long context attention in near real time. What does it even mean? Typically, if you try to increase the context window, you have to spend more time. In the worst case scenario, a quadratic time is necessary unless the entries of attention metrics are bounded. So typically you need quadratic time. But what this paper is trying to do is, this paper is trying to introduce a technique called hyperattention that can help you in improving context window with just near linear time. And they have managed to do this by using a technique called locality sensitive hashing. And if you see the benchmarks that they have got, hyperattention makes inference time of chat GLM 50% faster on 32K context window, while perplexity has gone up from 5.6 to 6.3. Perplexity is a measure that is used to measure the coherence of the output text from the generative models like large language models. On a much larger context length, like for example 131,000 context window with causal masking, hyperattention offers 5-fold speed up on a single attention layer. I already have got flash attention, we have got flash attention too. So this is hyperattention that improves upon flash attention. The next paper that we are going to discuss, MemGPT is trying to create like a virtual memory context where you have got like a main memory and external memory. We have already covered it extensively on a separate video, but to simply say that everything in MemGPT is considered to be an event, and the event is going to be the input inside the LLM system, which has created its own memory, and that can end in a function or a yield. It's not going to do anything. A function is going to either send a message back, update the query, or pause interrupts. And it also has got a code with itself, so you can directly go here and then try out their code that they have linked. And I think like this is one of the coolest setups that we have got in terms of how you can use LLMs to optimize its memory, which is a short-term and long-term memory, which has been one of the disadvantages of using an LLM beyond the context window. The next paper that we wanted to discuss is self-RAG. Self-RAG is a system that is trying to improve the existing RAG system. The RAG stands for Retrieval Augmented Generation. Self-RAG is trying to do something extra. So it's a self-reflection framework for RAG, Retrieval Augmented Generation, and critique through self-reflection. And we have seen a demo of how you can see that this system builds its own custom LM, custom large language model, that has got special tokens, like for example a retrieval token and also a reflection token. A retrieval token helps the model decide when the retrieval should happen, and the reflection token helps the model reflect of the quality of the retrieved documents and thereby give the best segment to the output. And this way you have got much higher quality of the output when you use self-RAG. And the authors also have tried the system on various large language models, and you can see that self-RAG always scored the top when you compared it with existing open source large language models. It's a very interesting system, to be honest, and RAG is quite important for enterprise setup, and any enterprise setup, to be honest, for you to have the factual data. And they have also managed to share the 7 billion model and the 13 billion model on Hugging Face Model Hub for you to use it. And if you were to do it on your own, you can also check their techniques that they've shared to see how you can use it on your own, like for your own large language model with self-RAG. It's a very interesting system. Kudos to the authors for sharing the entire detail online with open source license. The next paper that we are going to discuss today is Pali 3. It's from Google. You can see it's completely like a Google model. Pali is a smaller, stronger vision model. They've used a new image encoder that's called a SIG-LIP image encoder. The SIG-LIP image encoder is being used. You can go ahead and then see how the architecture looks like with the SIG-LIP. And you can also see what kind of benchmarks they have with the current state of the art models. See Pali 3 with 5 billion parameter and Pali X with 55 billion parameter, and it is being compared with other models. Surprisingly, this model doesn't make any comparison with other models like Edifex or QuenVL. Based on the benchmarks that they have got, Pali 3 seems to be a very interesting model. The next paper is another interesting aspect, which is towards foundation models for learning on tabular data. Most of the enterprise data are still in tabular format, and anybody who's been working in like large enterprises would know that while you have a lot of textual data in companies, still the key data, like for example your finance data, or for example your employee data or sales data, all these data are ultimately your tabular data. And tabular data can be considered a text data, but still it's not text data. It has its own structure, it has its own columns, and a lot of nuances are there. That's where we do not have a lot of even for example, even when you consider deep learning, still a good robust XGBoost model is better than a lot of deep learning models. And that is where having large language models for tabular data has been one of the quests that a lot of people are going behind. And that is where we have got this new paper from Microsoft that actually proposes a tabular foundation model, which they call as TabFMs, to overcome the limitations of current existing large language models for tabular data. I'm very happy that there are researchers still in 2023 focusing on releasing large language models for tabular data. The next one is called SkillGPT. SkillGPT is a service or a model. It is a combination of it. What it can do is it can use large language models to extract structured information from documents and job description. Sure, one of the place where the company spend heck lot of money is recruitment. If you want to start a startup, I think that is definitely one of the areas that you should target. They spend a lot of money in recruiting the right candidates. And I personally have built a resume parsing system way back, like 6-7 years back, using simple regular expressions, text classification models, parsing documents values from PDF. And it is a very hard task, to be really honest. Resumes are different formats, PDF is not structured, extracting content from it and then showing it in the structured way is a very hard problem. So what SkillGPT is trying to do is SkillGPT is trying to put together a system at the end of the day with all the things that we just discussed about, so that you can have structured information from either JD, job description, or resume. And you can see at the end how does the output look like. They've got a very nice demo here. You can see the demo. So you can just say what do you want to extract, and it can go from the information and extract whatever you want. For example, the label, the concept, the alt labels, all the information that you want can be extracted from unstructured information. That is what SkillGPT is trying to do. If you manage to turn this into a SaaS, I think you'll be making a lot of money. So basically used Llama and created SkillGPT, and definitely something that you should also try to do, and then probably launch a start. The last paper that we're going to discuss today is TableGPT. It introduces a new concept called table tuning. So we already know fine tuning, we already know instruction fine tuning, we know supervised fine tuning, we know continued training. This is a new concept which they're calling as table tuning. The objective of this is the way you do instruction tuning, which is required for the large language model to follow instructions. Table tuning particularly focuses the model to make better at understanding table understanding, so that the models can perform better with structured tables like the tabular data. Once again, this is from Microsoft. Very surprisingly, Microsoft seems to be investing quite a bit of time in improving large language model understanding of tables. The point that they're claiming is, while the large language models are better at one-dimensional task with natural language, they're not really good at relational tables, which are usually two-dimensional objects. So what this paper is trying to do is introduce this paradigm called table tuning and also demonstrate some capabilities. Especially if you go see what they have managed to do, you can see that they have done this comparison between instruction tuning and table tuning, and then see how the final response is. And you can see some demos here. For example, how table tuning improves the model's understanding of tabular data, which ultimately, inherently it's a text data in itself, and how does it do better in giving the output. It's a very interesting approach, and they've also listed the set of table tasks, like what kind of things that you would do. For example, you would do table understanding, table Q&A, table matching, data cleaning, natural language to SQL, data augmentation, and it lists all the tasks related to table, and based on that they have fine-tuned these large language models and try to show what kind of results they have got. And they have managed to also show that when they did table tuning, these models, the table tuned models, perform better than the vanilla ChatGPT, GPT 3.5 Turbo and GPT 3.5, which is quite interesting. Surprisingly, I don't see the benchmarks comparison with open models, but again, I think this should not be very difficult for somebody to adapt it for open models as well. But a very interesting concept that Microsoft has introduced this table tuning as a paradigm to fine tune large language models to make them better at table understanding. In the next section, we are going to look at 4 models with one extra approach. The first one is Fuyu 8 billion parameter model from Adept. It's a multimodal model, and the model is also available for you to use. That's why I put this under model section, not under a paper section. So they're open sourcing Fuyu 8 billion parameter model. It's a small version of multimodal model. Basically, they have got like a larger model that powers their product. The model is available on Hugging Face Model Hub for you to go ahead and then straight away use it. There are certain advantages of this model. One, the model has got a very simpler architecture, and the training procedure is also simple. That means you can deploy it at scale for easily. And Adept is a company that has been determined to develop large language models primarily for a digital agent. So this model has been also designed from ground up for digital agents. That means this model can support any images, answer questions about graphs and diagrams, have UI based questions, and all the other things. The model is fast. That means you can ask it question, and in less than 100 milliseconds you can get responses for larger images. And this model has been fine tuned for specific use cases like visual question and answering and natural image captioning. You can go ahead and then see how the model architecture is. This model comes with a CC by NC license. That means you can technically use this model even for commercial purposes with the right attribute if you want. And you can see the benchmarks here, how this model is doing, and a set of tasks. The good thing, unlike Pali, they have managed to compare this with Quen VL as well. And you can see how Fuyu 8 billion parameter model is doing. Definitely, the Pali X and the other bigger models are doing better than this, but this is a smaller model. That means you also get to see how this model is doing across various tasks. It's very simple for you to get started. I'm planning to explore this model separately on a separate video, but again, this model is a very interesting way how the large language models are being transitioned into the large multimodal model. There is one very interesting thing that I found in this blog post that they launched, is they're trying to explain why measuring or understanding these models are difficult. For example, what they're claiming is that whenever you try to see these benchmarks have some kind of pre-labeled values, and those values are always not good. So sometimes the benchmarks that you see may not be even really good, and that's what they're trying to see. For example, if you've got an image like this, Fuyu has captioned this, for example, a nighttime view of Big Ben and the House of Parliament. And if you see here, the reference caption that they have got does not have anything related to this. And because of this, the benchmark score might say that Fuyu is not good at this model or this captioning, while Fuyu has actually got the extra details which other benchmark references have not got it. So this is something that I found interesting, to be really honest. With a lot of models relying on these benchmarks that are available, what if the benchmark itself is wrong? And that's exactly what they've gone through in this article, which I kind of loved it, because we just take benchmarks for the face value. But anyways, Fuyu 8 billion parameter model is a smaller model that powers a larger SAS, and it's a multimodal model that is built from ground up for AI agents. Definitely looking forward to try it out. The next one is MistralLite. MistralLite comes from Amazon, who's been releasing these light models. Before also they released Falcon Lite. Now they've released Mistral 7 billion parameter models, the Lite model. Even though the model has got a name called Lite, the objective of this model is to be better at long context, that is up to 32,000 tokens. They've used certain techniques like a rotary embedding, sliding window during fine tuning, and because of that, MistralLite is able to perform significantly better on several long context retrieval and question and answering tasks. You can go ahead and then see how this model performed. And if you see on topic retrieval, Mistral 7 billion instruct model is here, MistralLite is here. And again, like these things do not matter, because Mistral does not have a context window over 8,000. So this would be definitely 0%. But you can see how good MistralLite has performed even for larger context like 10,000 context window. And you can see line retrieval, passkey retrieval, question and answering with long input context, where the base Mistral model is only 44% test accuracy, while MistralLite has scored 64%. On a very hard subset, the Mistral has scored 39% accuracy, while MistralLite has scored 56.2% accuracy. So the bloke has already released the three formats of quantization. So should be definitely easy for you to check it out even if you have got a consumer hardware. The next model that we wanted to talk about is OpenHermes 2 Mistral 7 billion parameter model. Comes from our star model fine tuner Technium. 7 billion parameter model was trained on 900,000 entries, primarily from GPT-4 generated data and also from open datasets across the AI landscape. And it uses the chat ML format. It has been fine trained using axolotl. So if you see the model benchmarks, I think it has got a really good benchmark result. If you see the GPT-4 of all 4 for all benchmark, it is just right next to the newest Hermes Llama 2 70 billion parameter model. If you see the AGI Eval benchmark, it is once again right next to the newest Hermes Llama 2 70 billion parameter model. In fact, it scores slightly marginally above Open Orca Mistral 7 billion parameter model, which I've heard like personally from a bunch of people that it does a really good job in answering a lot of questions. On big benchmark, once again, this scores almost as same as the newest Hermes Llama 2 70 billion parameter model. If you just compare averages, it is right next to newest Hermes Llama 2 70 billion parameter model. So definitely this model has scored really good on benchmarks. It follows a very similar chat template, which is a chat ML template that you can take from the tokenizer. This is another model that I definitely want to check out myself, and we already have got the quantized models as well for the OpenHermes 2 Mistral 7 billion GPTQ, GGUF, AWQ, all the quantization formats, and the model has come with Apache 2.0 license. The next model is the Arithmo Mistral 7 billion parameter model. It comes with Apache 2.0 license. This is a model that is specifically designed for math, and you can directly use it. It has got math as a data and also certain Python code for it. And if you see the comparison, you can see how does the MPT Mosaic model 7 billion parameter model and also the other models have scored. And if you see the Arithmo model below the wizard math and meta math models, those are like 70 billion parameter models. It scores above 13 billion model, 40 billion model, but these are general models. I think this model one, I like the score definitely. There is no question about how good the model is doing on math tasks. But I think what this model also proves that fine tuning for domain specific tasks are quite interesting and important. Creator of this model, Ashwini Jindal, has also open sourced the data set that has been used for training the Arithmo model. So you get to go see, okay, what is the question, what is the answer, how does the model dataset look like. So if you were to build your own domain specific data, I think this should like prove as a really good source for you, and also you can use this to fine tune other dataset as well. Speaking of which, Louis Turnstile, who is a part of Hugging Face, has created a wonderful experiment using the Arithmo dataset. So the math dataset, Arithmo dataset came. So Lewis wanted to try out the model with Zapphire's math capability to understand how this model would do on a chat model. Like the Arithmo model in this case is an instruction fine-tuned model. So you can ask question, it can answer, but it is not a chat model. It is not a multi-turn chat model. So what Lewis has done is, okay, let me go ahead and then use this with the UltraChat dataset and understand how this model is doing. And what Lewis observed is very interesting, to be really honest. This cyan color is UltraChat. This yellow color is UltraChat with Arithmo 25%. This orange color is UltraChat with Arithmo 50% and UltraChat with Arithmo 100%. And what you might notice is that yellow color and the orange color are really good. Like you can see in certain aspects. For example, for math, the UltraChat with Arithmo 50% is scoring the top on the math scores. On extraction task and STEM task, UltraChat with Arithmo scores 25%. Arithmo 25% scores above the base UltraChat model. And if you see the UltraChat with Arithmo on 100%, Arithmo 100% doesn't score good. So the potential reasoning that Lewis had got here is that maybe too much of math examples ruin the model's coding ability, and probably because the dataset Arithmo uses is a single turn dataset. You ask a question, you get an answer, but maybe it discourages the model to become more chatty. So maybe that could be the reason. But anyways, this is the advantage of open source and sharing dataset. Because Ashwini Jindal shared the dataset, Louis Tunstall could do this experiment on Zephyr's math capability, which uses UltraChat, and we also get to learn certain new things about how these models' emergent capabilities are. So, bottom line, Arithmo dataset improves the model capabilities overall on multiple aspects, not just math. Like for example, the yellow color here you see, you can see on math it is better than the base model, but on STEM it is better, on extraction it is better, on certain other aspects also it is better than the base UltraChat model in itself. But also you learn that okay, maybe it is starting to overfit, or maybe it is starting to do bad for multi-turn chat, so which is something that I just absolutely loved. So the next section is all about tools, techniques, and general news. Speaking of which, Spotify has released a new Vector DB with Apache 2.0 license, as if we do not have enough Vector DBs already. Anyways, Spotify has released a library for performing fast, approximate nearest neighbor searches on an in-memory collection of vectors, which is what a Vector DB is. So think of Voyager, the library name, like Sparky, but for vector embedding data. Two bindings, one is a Python binding, another is a Java binding. So if you were to build vector DB solutions or large language model solutions with Java, maybe that is a place where you would use Voyager. One is a very interesting blog post from LangChain. So it does a multi-vector retriever based on tables, text, images. It has gone through all the details about how you can use the solution, how you can build this for yourself, and this tutorial should definitely help you get it running. The next one, robot, like actual robot, not a large language model, and they have shown the demo. It's a company called Figure. It's an AI robotics company to build general purpose humanoid robots, and you can see how the model looks. All the demos are very similar, like the Tesla demo, but Tesla being Tesla, very big company, and when you see these startups trying to build these kind of models called dynamic bipedal walking, and I think this is quite impressive to see. Next one is from China. So Baidu, the Chinese equivalent of Google, has claimed that Baidu has got large language models that are of GPT-4 capability or Lambda from Google capability. It's a huge claim. We do not have a lot of insights about how to validate the claim. But Baidu has said that their Ernie, that's a model name, the Ernie 4.0 model will be featured across Baidu projects. When did you last use Stack Overflow? I can very well say, like, I've not used Stack Overflow for a very long time. I'm not sure if you are like that, but Stack Overflow has laid off more than 100 people as AI coding boom has continued. I think today we have got really good open source models that can help you in simple coding tasks. 28% of Stack Overflow team. It's like more than a quarter of Stack Overflow. So the last news that I wanted to cover before closing on a positive note is a new approach called Collama. As the name suggests, this is an approach that tries to use large language models with people. So right now, the way large language models data are prepared, or you either use an existing data set or you do something like, for example, take the data from that synthetic data from GPT-4 and you use it. So what Collama is trying to do is Collama is trying to see, can we bring people together in a Wikipedia style to have high quality data set and use that for large language models. They've said that they have got some good positive result by doing this, like bringing humans together, help them correct or validate the dataset, and then use that dataset to build or fine-tune large language models. It's still not completely open, but yeah, they have said like this is an interesting approach. LLMs plus people, and Jan LeCun, who is the head of Facebook or Meta AI research, has validated this approach, that this could be a really good approach to fight all the misinformation and everything else that is available. Now, a lot of you might say that Wikipedia itself is not successful in fighting misinformation. But again, this is a very interesting approach. So while typically people have used RLHF to validate the model results, which is again not a crowdsourced option, but this is trying to do a crowdsourced data validation, crowdsourced data building for large language models. Let me know in the comment section what you feel about it. See you in another video. Happy prompting.